So after discussing about levels of applications, components of applications, let us discuss about the possible application areas where a software and hardware can be partitioned. The applications areas which we are talking is about Internet of Things. Now here, what is the scope of the work? Is it a mini project, major project, or are you developing a product, or you are going for a research? In the previous two sessions, I tried to clarify what is the depth of knowledge involved in implementing the IoT applications. Let's say, for example, if you are doing a final year project, maybe BE or ME. When you are doing a project, what we see, like I said, a maximum learning should happen. The things which you are not learned. Let's say, for example, you are not aware of the compilers. So learning a compiler. You are not aware of the hardware, controllers, sensors. So learning about those, the devices. You are not aware of the protocols, right? Various OSI layers. So learning about the protocols. Or you are not aware of the cloud platforms. So knowing about the cloud platforms. And then by choosing any one of the application, you are supposed to integrate from top to bottom all the stages so that it's like a you understood each and every stage of a application layers. That's how actually happens in a project development. However, if you are going for a, let's say, product development, product development means, first, as I said, it's not available in the public domain. That means you need to look at some funded agency who is interested in your product, right? Or you want to develop a product, that means there has to be some creativity where people are interested in buying your product. So in a commercial angle, you have to see in the existing products, you have to do the survey on the existing products and find out that what is the value proposition you are adding to your product. So those aspects you have to bring it. Maybe you are reducing the cost, you are reducing the size, you are reducing the power consumption. Some USPs, right, selling points, you are incorporated in the product. So there is a possibility of you get some market. However, if you are doing a research in IoT applications, then you have to do exhaustive literature survey, right? Or maybe research, some industries also fund for your research. They give grants for research. In either case, your work has to be unique. So you will be contributing to the existing knowledge. That means there are some issues which are not solved yet in the market, in the industry. Those issues are your research objectives, right? So that's the difference of scope. If it is a mini project, let's say the worst case is a small project you want to do it, then the scope is about limited time. In a limited time, can you implement any application, a small application? You don't need to altogether come up with your own solutions. Learning the tool, learning the technology, quickly implementing the application is the scope of a mini project. But if it is a major project, at least 6 months to 1 year, if you are doing, then first define the problem, right? Like I said, I will show you how to define a problem. Then you have to do little bit of literature survey that in this domain, is there any other work is done or not? Try to compare your work, and then there may be a slight though it's a learning of knowing the technologies and implementing the technologies, but still there may be a slight incremental improvement in your work that may lead to some good publication. And since you are experimenting, definitely there is a possibility of going for a journal papers. That is the scope of the work you have in a major project. Now let us focus on the applications, possible applications, areas. There could be areas where you can think of consumer sector like home automations, like smart lighting, smart appliances, right? Lighting is the one which we talk about, street lights, home lights. The problem is about the saving the power, right? So can we make the remotely monitoring, remotely controlling the lighting system, or even some other products also like appliances, like refrigerators, air conditioners, any electronic load can I remotely monitor and control. Safety point of view, like intrusion detection, smoke, gas detectors. So there is a possibility of leakages or the theft. You can monitor them remotely, or when you are not at your house, how to plant the your garden, how to take care of their water, or the maybe aquarium feeding the fish, and so on. So these are a small appliances you can think of which you see day to day life, where you want to do through internet of things, means through developing a mobile app or a cloud GUI. Remotely you want to monitor them and control them. That is the scope. However, if it is a major project, then you need to first do a little bit literature survey and try to justify that what way you are proposing different. And as maybe another feature, small value addition you will be doing to the existing work. But if it is a research, then like I said, that there are some issues. There is no bad problem, right? Every problem is a good problem. Even a home automation could be a research problem. Unfortunately, there are some misconceptions. In home automation also, if you try to solve some issues which is not solved by existing industry, that could be your research problem, right? So, uh, so the other applications could be cities, right? Like we have a huge problem of parking or lighting, smart roads, structural health, like buildings, right? You want to know the health of the like bridges, buildings, towers, and so on, and the surveillance, right? You would like to monitor the streets, and so those could be the possible applications through remotely you would like to monitor and control. Similarly, the environment related things like weather monitoring, pollution monitoring, noise monitoring, or fire detection is a big problem. Forest fires, river floods is again a big problem. The problem here is these are all 24 by 7, 365 days you need to monitor them, and a huge data is generated. So you need to come up with some solutions from prediction, detection, and some action should take place. But it is almost difficult employing some right people there, because these are the things happens in all. It has to function in all weather conditions, maybe extreme conditions. So there IoT comes into picture. Then energy. Today, the power generation, power distribution, like I already explained in the previous session, is a $1 trillion industry. So when you talk about the power grids or renewable energy systems or the vending machines and so on, so these are all are the battery charging stations. Today we have electrical vehicles. So it's a big industry, and the and it's also related to not only about the distribution, it is also related to business. Online transactions takes place. So how do you build such kind of a business models for electrical stations or electrical distribution systems, power distribution systems? In retail sector, we know like big markets, right? And the like inventory management of all the products, smart payment systems, smart vending machines. So these are some applications which comes under retail market, because the number of products are in millions, and then monitoring them and then payment refunds is a big beyond imagination, without any automation. And since they are globally connected, so people wish to track them through some internet of things. Logistics are given example about the route generation, scheduling, tracking, shipment monitoring, and all, where right every vehicle, or even if you park a vehicle, monitoring your vehicle, any theft is happening or not, alarming, and so on. Agriculture applications is again a highly unorganized sector. Nothing much is done. Lot of things are still yet to be done. Highly unpredictable, because it works on a highly unpredictable weather conditions. But definitely it is a most important sector, because without food, nothing can be done. So a lot of things are yet to be developed in smart irrigation system, greenhouse control, etc. The challenge here is they have to work in extreme weather conditions and low cost. It should be affordable solutions. And where IoT comes into picture, because the data which is generated and the communication it has to do is a huge and large. We are majorly working for the industrial IoT applications, also education sector, where machine diagnosis, it is one of the uh, highly demand area, like ABB, L&T, or Bosch. So many industries, their machines are remotely monitored and controlled. And then the air quality and all in the within the industry and so on. Healthcare sector, particularly in developed countries, healthcare sector is a business, highly invested business, because there is insurance companies are involved in this. So the health monitoring and the wearable electronics and all is a big business models in the healthcare sector. So remote monitoring of the patients, intensive care units, etc., is what is the business models. All right, so that's how you can look at IoT application, the demography in terms of wearable devices, smart appliances, smart buildings, smart homes, smart TVs, smart farming, smart health, smart city, smart cars, and so on. So what is that smartness? Smartness comes because of the sensors. Smartness comes because of the algorithm in it. So that's where your, as an engineering point of view, your whole focus is about the mathematics. All right, so let's look at the IoT platforms and systems. If you choose the application area as IoT platforms and systems, we also have some funded projects, like IoT Mobile Lab is one of our product, where we are looking for learning management system. So we need to develop a mobile lab for hands-on IoT learning, incorporating learning management system for tracking and progress and assessment. So let's say if you have a educational institute, the institute has adopted the learning management system and we are providing the IoT mobile lab kits. So a candidate may be in the lab, the candidate may be they're at home. Whenever they are doing some coursework, the entire data of that IoT kit should be available on the cloud platform. The faculty should be able to analyze the data remotely, do the grading and so on. Today, teaching is happening online, but not the IoT platforms online. So that's the concept of learning management system and IoT lab. Similarly, development of a platform for demonstrating various IoT protocols. Though we have some commercial platforms for demonstrating the various protocols for implementing various applications, we can also come up with your own open source sort of a toolboxes for demonstrating IoT protocols. This could be another application area where we are looking for. We also have a single board computers like Raspberry Pi Pico W or mobile lab or maybe some other controllers. So if you are willing to develop the application by using altogether a different controller, it's a excellent work because the work which we have not done, not currently available, is also lead to a good contribution. We are not talking about Raspberry Pi boards. We are not talking about Arduino boards. They are actually banned in the educational institutes. We are talking about designing a system on your own by using controllers and then develop a platform. Study and analyze various performance metrics of a IoT platforms. So what you have to do is, if a platform is given to you in this project, where the platform performance, you have to define some performance indicators and then analyze them, strength and weakness. How do they perform? Let's say, for example, today you have some benchmark softwares. Like say, if you want to buy some computer or workstation. So when you do this, you use some benchmark, you run some benchmark softwares to verify how it is performing. So same thing happens here. You have to develop some benchmark tools to analyze the platform which is developed. That could be a possible application. We also have a analog and digital mobile lab. It's again a altogether a different invention. It's not just a digital, even analog, the most complicated part is the signal is amplitude is continuously changing, frequency is changing. So if such kind of signals are available, maybe high amplitude signals, then how do you acquire the data? How do you communicate the data? How do you analyze the data? Like a spectrum analyzer, right? We all know the expensive analyzers. So can we implement like a spectrum analyzer for analog signals? So these are called platforms, right? Means you are providing it itself is a product. You are developing a platform where it could be a product where several people, either in academics or in industry, people can use it. Let us look at the application area where the amount of data is huge in size, maybe gigabytes and terabytes of data, that too in real time. We know most of the appliances nowadays are battery operated systems. like drones, mobile phones, electronic gadgets, electrical vehicles, satellites, right? They're all sourced through some chargeable systems. So when the system is having when the system is consuming a lot of resources, sometimes you also need to think of optimization of the power consumption because of the life of the battery. Once the battery is the most expensive component in any of the systems, so it is also useful to write a scheduler, develop a algorithm based on the power consumption of various resources. And also the CPUs are multi-core and heterogeneous in nature. Even these cores, based on the application, they consume a lot of power. So this itself is an interesting application, IoT application for multi-core heterogeneous system for optimization of the power consumption. The other application area is PV solar performance analysis using IoT. We can understand these photovolatile cells, they are not at your nearby places. They may be on rooftops, hill stations, deserts, nowadays even on the riverbeds and so on, canals. So if you want to analyze their performance, then the data has to be 24/7, all seasons, 365 days. The life of the cell may be 15 to 20 years. So you need to analyze their performance because huge investment is involved. So it's a truly IoT application because the data is huge and the systems are not reachable, right? They are not at nearby places. They are at some high altitudes or remote places. The another area is concentrated solar power. Again, here, though it is not a PV system, but still it is because of the power concentrated on a mirrors. So whatever is the power generated because of the various environmental conditions, so one need to analyze the conditions of the environment and the amount of power is generated. The reason is the finally that power is contributing to either electricity generation through turbines or the steam is used for some other heating or cooling applications. So again, it's a huge data. The another area is the entire power distribution system itself, right? The several power generation stations, right? There is a hydropower, nuclear power, or the thermal power, solar, windmills. When so many power generations systems are contributing, so we need to analyze at any given point of time the bidirectional power, that is the load and the source, is it balanced or not. So it is again a real-time data, huge data 24/7 one has to acquire and analysis and visualization at some remote monitoring stations. Let us look at the computing and data analysis. When I talked about the IoT ecosystem, the computation could be at the edge level, the computation could be at the fog level, the computation could be at the cloud level. So one has to take up a application where you should prove the performance of the system, what is the model you have selected, and that model when it is running on the edge side, fog side and cloud side, what are the issues right? What are the performance issues and what are the assumptions one has to make while developing that particular application. It's a good idea for computer science students to take up such kind of a applications, because finally you are talking about the smartness of a system, and the mathematical model consumes how many resources, it's a question mark. Then about the multi-channel data visualization and analysis. Looking at your application, right? Let's say when you have multiple parameters to be monitored, that means it is a multi-channel data. So that data in real time, if you want to visualize, maybe on your mobile phone, maybe on your computer, then what kind of data acquisition, data analysis you develop, so that looking at the bandwidth of the data, that is the frequency of the signal, that to multiple channels, how do you divide your screen into various accesses, right? And then the data, how do you communicate the data byte by byte or a packet by packet, file by file? How do you transmit the data for multi-channel data visualization and analysis? You can also take a application and you can implement this multi-channel data visualization. These are all expensive applications, but then it is worth attempting indigenously developing these things rather than buying a proprietary expensive solutions. We also have a product for mobile lab application, but then since the mobile lab platform consists of several resources, right? Can we develop a real-time operating system so that all those resources can be scheduled so that one can demonstrate a multitasking application? So your scheduler may be a general purpose in nature, but the user is selecting which application to run at any given point of time. So that kind of a real-time operating system need to be developed for the mobile lab, the product which we have developed. Some of them are funded projects, right? So like we already discussed about what do you mean by smart home and smart cities. It may be a smart lighting system, automation of the home lighting based on the occupancy, how many people are there, and natural light, how much natural light is available. That will reduce the energy consumption. Similarly, smart thermostat, design a thermostat that adjusts the temperature, because we can understand the particularly the western side, they have a temperature problems, right? So they may be having heaters and so on. So based on the temperature, they need to control their daily heaters and so on. They consume huge amount of power, and the weather forecasting also. Home security is another area, because you want to monitor your entire system, entire industry, entire your warehouses or personal homes. Then depends on the locations, you need to use types of sensors, maybe motion sensors, cameras and so on, and remotely it is monitored. Smart parking system takes care of the available free spaces, guide the drivers and reducing the searching time and the congestion. Smart street light creates street light that adjusts the brightness based on the movement, so that when people are not walking, maybe after 10 o'clock, then it will take care of automatically either reducing the brightness or switching off the lights. Because this is all, they're all, you can understand, megawatts of power is being wasted because they are not used, right? So automation can take care of these things. Traffic management, we have a pretty old traditional traffic
control systems without using any sensors, where the amount of the on time and off time of various lights is fixed. They are not taking care of the traffic. So it's a one of the typical problem. But since IoT is in place, so they not only use the sensors, but then also they communicate, like you have a Google Maps. That means they're all the traffic lights could be networked, so that there could be a smart algorithm which will be running, which can predict and suggest the direction, the traffic on time and off times, or the emergency traffic systems, and so on. Such kind of systems are yet to be developed. Waste management, monitoring the waste levels of the bins, and the collection time, reducing the cost and environmental impact, because these are all really challenging issues for every cities, because the amount of garbage on daily basis as to there is no proper management systems in place. Also the food wastage and so on. If you save the energy, if you save the amount of waste of food, if they save these resources, it is as good as you are actually generating the resources. Actually, you are contributing to the reducing the global warming and so on. Healthcare is a billion-dollar industry, particularly in Western world. So remote health monitoring, there are already some systems are already in place, but people are looking for some innovative ideas and smart devices. And they need to be connected to the databases, because some insurance companies are involved. So you need to provide the evidences, and also the mobile, the doctors, mobile healthcare is the need of the hour. Like in COVID, we have seen the whole world is functioning remotely with the help of information technology. So designing a system for monitoring vital signs and sending the data to healthcare providers in real time is all about the remote health monitoring systems. Medication reminders, because some patients need to be informed time to time because of their a different kind of illness, right? So a programmable systems which will generate the alerts or the amount of dose to be given and so on. Smart pill bottles, develop a pill bottle that records when it is opened, ensuring medication is taken on schedule and so on. So it's not only limited to the humans, it is also related to uh, the animals, or the forests and so on. Because see, the day by day, these rare animals, they are getting vanished. So these kind of technologies can definitely help in monitoring such kind of a remote places, because it's not possible to reach on daily basis to those deserts or the deep forests and so on. So a wireless sensor networks remotely monitoring the health of such kind of animals really will help in saving these rare animals. Agriculture is unfortunately neglected sector, but it's the most important sector, because day by day the soil, the fertility is reducing. Hardly few years are left where all irrigated lands may become deserts, because we have exploited the soil. If you listen to Sadhguru, he will give the statistics. So soil moisture sensors, control irrigation, optimization of the water. These are all actually implemented in some countries like Israel and some places where water is very precious. But unfortunately, we have exploited the soil. So this is again a alarming for the coming generations to come. Livestock monitoring the health of the livestock and with the help of some wearable sensors and GPS systems. Again, the governments are investing in the huge amount of money in livestock, right? They need, and they are getting wasted, spoiled. So time to time, they need to be monitored and then communicated to the respective agencies. Crop monitoring with the help of the like drones, etc. Because again, a drone is a flying object. A lot of funds are nowadays governments and private agencies are providing. The reason is, this remote monitoring, right, of these some of the crops, right, and their health is daily basis is not possible, and the wastage of fertilizers and pesticides that can be saved with the help of the drones. So the coming generation, and then uh, the environmental conditions. So it's not possible every time to climb those to go to those kind of a remote places. So there, these robotics and drones, remote controlled monitoring system comes into picture. So the need is here, the data is huge in size. Bandwidth might not be very high because the signals are maybe low frequency signal, but it is a 365 days 24 by 7 monitoring for the health monitoring and the uh, maximum utilization of the resource, optimal utilization of the resources and the quality of the foods, and particularly the organic, reducing the chemicals and the pesticides and the fertilizers. Otherwise, most of the diseases like cancer and all is because of this excessive utilization of these chemicals. Probably IoT can give you solutions in this domain. Industry undoubtedly, like I mentioned, ABB or Bosch, right, L&T, several industries, right, I'm talking about local Siemens and all, they are already implemented all their manufacturing sector. The machines are continuously monitoring their performance 24 by 7, and then they predict the failures so that they can maintain the scheduling, like turbines, say for example. They need to be monitored when it is going to fail. There is a possibility that the minute cracks that may lead to a huge damage to the entire power plants. So is the energy, which I already mentioned, warehouses we already discussed, right? Air quality monitoring, water quality monitoring, weather stations. So these are all various applications based on the who is your customer. The customer could be an industrial customer, the customer could be an agriculture customer, the customer could be a healthcare customer, but finally some of the parameters related to moisture, temperature, or the humidity, right, radiation, they may be significant for different applications, right? So application may be different, but sometimes the parameters may be same, but your mathematical model may be different because finally there will be some uh, prediction and correction has to be taken care by using these IoT solutions. Similarly, in education sector, right, like smart attendance system, we understand that not only in educational sector, in industry also, the record generation, because your entire academics or the credits or in industry, your salary, everything is connected to the your work. Similarly, interactive learning system. right? This is one of our product which already mentioned about the mobile laboratory, campus safety, uh, where particularly the places where some remote places there is a possibility of the theft or the floods or animals. These are all some issues. So 24 by 7 monitoring is difficult. So better to have these IoT based systems in place so that they generate the alerts during the emergencies. We also can think of some latest technologies. Even we are willing to fund some of the latest technologies like LoRa Wi-Fi communication, the modern wide area network communication systems, or digital communication, right? Integrated development environment, latest protocols, right? Exploring various uh, uh, cryptography techniques and so on, even in this domain. Or see, the our products are having the base boards and the daughter boards. So the base board may be same, but then if you can come up with these daughter boards based on the some latest technologies like digital signal processing for audio or video processing, or electrical vehicle IDEs, or real-time operating system for some of the scheduler-based systems. So these are all the cutting-edge technologies, state-of-art technologies. Instead of building the entire system, we are willing to fund for the IDEs. So if you are interested in integrated development environment, because these are yet to be explored. So we will come up with our own designing the IDs, and they could be part of our baseboards which are having a IoT platform. So your job is to develop the daughter boards so that you can do the evaluation of the new technologies. So these are all some miscellaneous applications. Some specific case studies also, use cases also one can take up, like architecture, IoT architecture, or the remote monitoring of the industrial applications, HMI for the 5G base stations, HMI for the industrial induction heating systems. Because we have some funded projects through industry or Department of Science and Technology. The projects are already in place, but then some of the solutions can be developed. For example, human machine interface for a induction heating system, or we also have the funded projects for the base stations need to be monitored uh, uh, by with the help of some HMIs or some other remote monitoring of some industrial applications. We also recently got a project for um, uh, a reconfigurable system which can be implemented for multiple communication protocols. Uh, that is again like a gateway. The gateway should be in such a way that it should have the ability to adopt for multiple communication protocols. So such type of problem statements, actually funded problem statements, where we can fund whatever is the components are required or whatever is the investment required, we will fund, we will guide you. Only you need to dedicate your time for implementing and validating the systems. A small contribution also well appreciated, because these are all the projects which are not implemented, right? There are some projects which are for learning purpose. Like already said, that a mini project has a different scope, major project has a different scope, product has a different scope, research has a different scope. So you have to look at the purpose of doing or implementing the things. So what we do generally is that first you need to understand what do you mean by real-time system. What do you mean by developing your own industrial coding? I repeat, the way we write the code is not a industrial code. We write the entire code in one single loop. Most of the subjects, most of the practicals, the code is in one single loop, which cannot be used in the products, right? The code has to be multitasking. The code should have deadlines. The code should have priorities. The code should take care of the real-time issues. So that is how code has to be written. In short, you should be a really good coder, industrial coder. So keeping in mind, we have developed a low cost solution for single board computer. Looking at all those above applications, right? Can we have a common platform so that some of the components are mandatory, some of the components are optional. Based on your application, you can fabricate, right, those components on the board. So that's how we have designed our own single board computer. You are not supposed to use Raspberry Pi boards or Arduino boards. They are general purpose. But here, if you want to change the CPU, we can change the CPU. If you want to change the peripherals, we can change the peripherals. If you want to altogether design a different PCB, we will support you to design your own single board computer. So that's what we need to have, those skills, that you are a designer, you are a developer, you are an innovator. Then you can patent it, you can start a company, then you will get some investors who will invest in your product because you are not using the existing hardware, existing software which is available on the public domain. So there is a confidentiality is involved in your design. So keeping in mind, we have designed this thing as a training programs. You can join us either through internship programs or weekend hobby clubs. Internship programs could be as and when you have some semester breaks, you can join us. But hobby clubs means as and when you either weekdays or weekends, whenever you have free time, you can join them. These are all a systematically programmed skills. One has to do it. To begin with, we talk about the what is hardware, what is software, what are the signals, right? What are the mathematical models, how to make use of various peripherals, how do you fabricate, right from soldering, testing, troubleshooting the components. So that is the first part, I would say, of build your own single board computer. Absolutely no assumptions. One has to build on your own. And if you do this maybe in one or two sittings, then this hybrid internship is also possible, where from your house itself or from your college itself, you can implement the application which you have chosen, right? That could be your mini project or major project, or maybe your own innovative ideas. So that is how we can help you out. Once if you come to one level, at least, right, the minimum basic skilling, if you do it, then application we can definitely guide you. Or also we can help you out in writing the proposals, funded proposals, because you understand what are the do's and don'ts while developing the IoT products. All right, so these are the some videos which are there on YouTube. But as and when you join our coding club or internship program, we'll make sure personally we'll guide you time to time. And while writing the project proposals, right, there are some rules one has to follow, because these are all technical documents, right? It's not any commerce or arts documents. So naturally, the contents, the while writing the technical documents, we prefer latex tools rather than Microsoft Office. The reason is latex is a actually it looks like a compiler. It's a scripting language. So naturally, whatever is the text you generate, it converts into various file formats like PDF, JPEG, and so on. Already explained in these videos. Uh, See, if you use the Microsoft Office, you are tempted to use a lot of the fancy things. different fonts, different animations, different styles, and so on. And your figures will be shifted from back and forth as you keep on inserting new content. So it's a literally you will be keep on editing your own document lifelong. However, if you use these open source tool scripting languages, maybe initial stage it may be slightly painful. Later on, you will enjoy using these languages. That's what is mentioned in this video, so I don't elaborate much on it. I request you to go through these videos, which I kept it in the public domain. But documentation is very important while doing mini projects and major projects, because you are not supposed to make any mistakes while documentation, because they are technical documentation. They speak about your work. So no copy paste things from the public domains. That's the reason it should be precise, as small as possible, but your own contents. So I will end up here saying that go through these videos. I have explained every single point, the significance and how to create these documents, including your presentation, what is the significance of your presentation, and some open source tool for drawing the figures, plotting the data, analyzing the data, and so on.